Well, good morning, and I am sorry I cannot speak to you in Spanish. I have, I really want to learn Spanish, but I haven't made much progress. So I will have to speak in English. Also, as you can see, I have many microphones on me all over. Okay, so you don't actually know if I'm speaking or I'm only moving my lips and someone else is speaking. Okay, there's no way to tell, and that perhaps will form a little part of what I have to say about the future that our children will grow up in. So, to begin with, there are two kinds of futures that I want to talk about, and I have actually two lectures planned, this one and another one on Wednesday. Today, because we have many teachers here, I will focus on what happens to schools. Where will schools go? And on Wednesday, it's a more ambitious topic. What happens to learning? Learning, knowing, these are very important things for human beings. But what will happen to them in the future? So think of it as two bits. They're interrelated. What happens to learning and knowing obviously will determine what happens to schools. But first, let me start by giving you an idea of how I got into this whole subject. Let me see. I don't have a formal background in education. Okay, I didn't study education as a subject. My subject, what I learned in college and what I have in my PhD in, is in theoretical physics. And at the time when I studied physics, many years ago, at that time, physicists were the only people, physicists and mathematicians were the only people who knew how to write computer programs. So we were in great demand, not for physics, but for writing programs. So I got a job in New Delhi, in India, teaching people how to write computer programs. And it was a good job, and I was enjoying myself, except that in a developing country like India, you have two kinds of people. So I had the people in my students who were obviously the children of very rich people. And just outside of my office in Delhi was this big, sprawling urban slum full of children. So when I used to walk into office, I used to think to myself, am I not missing many very good programmers inside that slum? And why am I missing them? Because I can't build a school there. Nobody wants to build a school there. So we are missing a certain part of our human resource only because of money. The people who can afford and the people who cannot. So is there a way to do something about that? Well, I couldn't think of anything. I can't get a teacher to go into the slum. I can't build a school there. But I thought I could do one thing. I could take a computer and give it to the children. So people said, but how will you give a computer in a slum? Because there are hundreds of children there. One computer. So I said, well, I'll take a stretch of wall, I'll cut a hole in it, and I will embed the computer inside it, like an ATM. And I will keep it 3 feet off the ground. I'll connect it to the internet, and I will turn it on. So in those days, this is 1999, so almost 20 years ago, people said this is an absurd experiment. What will they figure out? They don't know what is a computer. They don't know what the internet is. That situation has changed today, but you must throw your mind back to 20 years ago. So what are you trying to achieve? And not only that, the children don't know any English, and the internet on those computers were in English. But I went ahead and did the experiment anyway, because I wanted to see what would happen. Well, we put the computer in the wall. As you can see, that's my office behind. And children obviously came to the computer immediately. After about 8 hours, we noticed this. An 8-year-old boy was teaching a 6-year-old girl, very short girl, how to browse, how to move on the internet. And then hundreds and hundreds of children all coming there. So people started to ask me, how did you teach them? And I said, but I didn't teach them anything. I just left the computer there. They didn't believe me. Even the press did not believe me. The press said that the children are surfing on the internet, and this man says that no one taught them. How is that possible? So they asked me, how is it possible? And I said, I don't know. Because I really didn't know what was happening there. So the World Bank funded an experiment stretching across the length and breadth of India to see if this would happen everywhere. And we got the same results everywhere. So the big question, who is teaching them? And I said, I don't know. So I did some measurements. I took a computer literacy scale, how well you know computers. And I took time, and at each of the places where I had these experiments, I took random samples of children and measured them every month for 9 months. And we got this straight upward learning graph. But this is what happens when a teacher teaches. Every day the children learn a little bit more. Where is the teacher? How am I getting the same learning curve as a teacher, but without one? Once again, I didn't have an answer. But I got interested in trying to find out what that answer could be. So I started doing some other experiments. I tried the following, you can try it also. This is a very simple experiment. In non-English speaking countries, if children are taught English, they may learn the language, but their pronunciation is poor because they copy the accents of the teachers. And this is a problem everywhere. How do you correct the pronunciation? You can't, because you'll have to import teachers from some English-speaking country. It's expensive, not practical. So I did something else. I bought a really inexpensive program. Nowadays you can get it for free. It's called speech to text. And I put it in the computer. So you know what it does, all your phones have it. You speak and the computer types. So I got some children and I told them, well, speak into the computer. So they said something in English into the computer typed everything wrong. So the children laughed, they said, the computer doesn't understand anything of what I'm saying. So I said, okay, why don't you do this? I will leave this computer with you. You try and make yourself understood to the computer. And I left them for about, I think it was 2 months. This is all published, by the way. You can get it easily on the internet. So. Okay, to my surprise, in 2 months, their accent started to change. They spoke more slowly, they pronounced each word more clearly. And not only that, with one computer, the pronunciations and the accents of 20 children changed. So, once again, the question, who taught them? And once again, I said, I don't know. It just happened. So we measured changes in pronunciation with a native language speaker and students, and changes in pronunciation with an automatic speech to text. And you can see that now they are identical, the two curves. One is taught, the one below is not taught. Something, or I don't know what, was teaching the children. What could it be? So I started, I did another experiment. In those days, and also today, you know, governments are very concerned about the quality of schools, not just the quantity. Earlier in poorer countries, the government was interested in quantity, that how many schools do we have. Now, many countries have many schools, so the question is, how good are those schools? So I took some of these government tests of how good their, 3 subjects, English, mathematics and science. I took standard government tests, and we took a car, I hired a car, took it and drove out of New Delhi further and further into the countryside, far away from cities. And wherever we saw a primary school, we stopped and gave this test. We came back to Delhi, totaled up all the marks and plotted a graph. Distance from Delhi against performance of the schools, and got this rather strange looking graph that the deeper you go into the countryside, the more remote the place is, the worse the school results are. I thought, well, is this only in India? So I started looking at some other countries and noticed very quickly that it is actually quite worldwide. And there are many explanations for it. Poorer areas perform badly. Remote areas perform badly. Why? Well, the answer turned out to be very simple. Teachers are human beings. They like to have a good standard of living. They want safety. They want good education for their children. So where do they go? They go to the better areas. The poorer areas get left behind. A strange problem. What does this graph tell us? It's telling us that good teachers don't go to schools that need them the most. Ironic, isn't it? That the best schools are in the best places. The poor areas which need good schools don't have them. What can we do? Well, I looked at the graph and I thought, if there was some way that these children could learn without a teaching infrastructure, then maybe that graph will not look like that. Of course, I was not very popular at that time for saying this. Everybody said, what do you mean? I said, look, I'm not saying that you don't need teachers, but where you do not have teachers, you need something else. You can't just leave the children. In the meanwhile, the hole in the wall experiment that I told you about, I had completed the study, but the computers were still there. And the local people in these villages were telling me that, you know, the children keep going to that computer and doing something which we don't understand. So I said, what? And they said, we don't know. But instead of, if you ask a child, would you like to go to school? He will say, well, I will go to school, but can I play with the computer? If we say, would you like to go and play? And they would say, yes, I would like to play, but first, can I play with the computer? So I said, so do they play only games on it? And they said, we don't know. We don't know what they do all the time. So I did an experiment. This is in a village where there was a school, a primary school, with 12-year-old children speaking a language called Tamil, an Indian language, South Indian language. Not a word of English. I gave them a hole-in-the-wall computer and I downloaded some university-level material on biotechnology, okay? Years and years ahead of their time. I downloaded it into the computer. So the children came running and said, what is it? Is it a new game? I said, no, it's not a new game, but it's something very interesting, if you can understand it. And then I left. I came back after a couple of months. You know, before leaving, I had given them a test. And obviously, they all got zero, almost zero. After 2 months, I came back and I gave them the same test. And noticed you know, if you listen very carefully, you'd be able to hear. 2 months later, when I came back, I found these little 12-year-olds talking to each other and saying things like neurons, genes, technology, biology, etc. And when I tested them, I got this. There are 3 bars there, if you notice, and what we saw was that the scores would jump from about 0 to about 30%, which is fantastic, because you know they're dealing with university level material in a language that they don't know. How is it possible? But anyway, 30% is not such a great score. So I tried another little experiment. There was a local accountant, a young woman, who was friendly with the children. So I called her, I said, can you help them to learn biotechnology? And she said, no, I mean, I don't know any biotechnology, I'm an accountant. So I said, no, use the method of the grandmother. So she said, what's that? I said, just stand behind them and every now and then admire them and say, wow, how did you do that? What comes next? Like that. She did that for 2 more months and the scores jumped from 30 to 60. The third bar on the right side is a rich school in New Delhi with a trained biotechnology teacher. And back in my South Indian village, the children, with the help of the grandmother, had gotten to the same level. Who was doing this. We still didn't know. Back in England, I made an appeal in a newspaper saying that if you have an internet connection and a web camera, and if you like children, then can you give me 1 hour of your time every week for free? And I got hundreds and hundreds of people. I explained to them the method of the grandmother. I will beam you over Skype into some remote place. You talk to the children. You don't have to teach. Just talk to the children. So what are you doing today? What are you going to do tomorrow? Oh, you're very clever, very nice. The grandmother's method. That informal group still exists today with hundreds of members. It's called the Granny Cloud. Okay, because of the method, not because it's made up of grannies. So basically, you take a school or an environment somewhere and you get the projected teacher, not on a tiny screen because that's no fun. It should be a life-sized image. So it looks like a real person there. Sometimes little children go up to the screen and look behind to see if there's anybody behind. Okay, so you get the idea. Very simple, very effective, if you can organize it properly. So back in England, something very interesting started to happen. People in my university, I work for Newcastle University, people in Newcastle University started noticing the work and asking the same questions that I had heard in India. Who is doing this? Where is the teaching happening? And I would keep telling them, I don't know. So some of the schools of Gateshead, if you imagine the map of England, Newcastle is very close to the Scottish border. It's about 300 kilometers up from London. It's a coal mining town, very much like your Lota. But of course the mines are no longer there. It's on a river called the Tyne, and across the river is another town called Gateshead. I live there. So I went to the local schools of Gateshead, and we did the hole-in-the-wall experiment. How do you do it in England? It's very simple actually. By the way, this is something you can try very easily. Take any classroom, if possible move the furniture. If you have 20 children, take 5 computers for 20 children. Why? Because remember, in the hole in the wall, what were the 2 important components? One was the internet, the other was that there was 1 computer and lots of children. At that time, I used to think this is a defect. If I had lots of money, I would give 1 computer to every child. Today, I know that that would not have been the right thing to do. So take your classroom, let's say you have 20 students, you have 5 computers. I would say, don't use computers which have tiny screens, okay? Like little tablets or things. Use big screens. Put them in the classroom such that from any point in the classroom, you can see all the 5 screens and what's on them. And so can the children. So if I'm in a group of children on a computer, we are doing something, I can look around and I can see what other groups are doing. Very important. All of these are very important. So you do that, you do the setup, then you ask the children an interesting question. Anything. You have to think of something really interesting. Don't ask a boring question. To give you an example, once in China, I was doing this experiment. The question I gave them was, how does your smartphone know where it is? So the children said, what do you mean? I said, you look up on map or whatever, and it shows you with a dot, you are here. How does it know? So the children said, how does it know? So I said, well, you find out. You've got these 5 computers, they have internet connections, you figure it out. So they rushed in, started working with a lot of noise, shouting. They came back after some time and said, GPS. So I said, well, that doesn't impress me. It's only a word, GPS. What is it? So they said, can we have 10 minutes more? I said, yeah, go ahead. So they went 10 minutes more. Then they came back. And then they said what I felt very happy about. They said, Sugata, there is a subject called trigonometry. So I said, oh, and what is that? It's something to do with triangles. The cell phone looks for 3 satellites or 3 towers, and then using trigonometry, it figures out where it is. So just to test if they like the idea, I said, and would you like to know how trigonometry works? And all those little fellows said, yes. So then I was talking to the math teacher, and I said, have you ever seen any class of children who are so keen to learn trigonometry? And he said, no. So that's the way to do the hole in the wall inside a school. I gave it a name. We called it a self-organized learning environment. I'll talk about that in a moment. But what I did was a set of experiments in Gateshead and another similar set of experiments in Uruguay. What the experiment was you may find it hard to see that graph, so I'll explain it to you. I would give groups of children a big question from their end of school exam. So let's say the children are only 10 or 11 years old, and I give them questions that they will face when they are 17. They get excited by this. I would tell them, this question is meant to be answered by 17-year-olds. But suppose I give you the internet, can you figure out the answer? And they would go for it immediately. In fact, in one of the schools in Gateshead, the children, did some pretty complicated question. And after that, I said, wow, that's terrific. How did you do that? And they said, this question was for 17-year-olds. I said, yes. And they said, well, 17-year-olds must be really stupid. So I said, well, that's the internet then. What that graph is showing are 3 different subjects: molecular biology, a bit of physics. I can't read it very well here. But I was measuring 2 things. One is, what's the score? The other is, if I come back to the school after 6 months and ask them the same question again, but without the internet, can they answer it? And astonishingly, they could, very easily. So I had learning happening, and I had good retention. Oh, what more can you want? What was I doing as a teacher? Making a nice question. So we call this a self-organized learning environment. The name is obvious, what you are doing is you are enabling the children to learn. You're not teaching. Why? Because you may be a very good teacher here in a very good school in Concepcion. What about in the remotest parts of your country? Where will I get you from? But could I get teachers who know how to enable rather than teach? Then perhaps I can get them everywhere. This is what it looks like. So I think you get the idea. So here's the teacher posing the question. It's a pretty complicated question for 9-year-olds. And here is the soul. And then the answers. So various children dealing with various questions. This last example was an interesting one. I think I did it in the US, perhaps. The question was, why do we dream? And children were 9 years old. So they came up with all kinds of theories. Oh, dreaming is about what happened yesterday. Dreaming is about something to do with the past. Or dreaming is about what I want to do next. Something like that. And they were saying some sensible things. My time ended, and just before the end, this little girl came up. And she said, you know, there was a man called Sigmund Freud. And I said, okay, let's finish. So, in 2013, I got this prize. It's called the TED Prize, and it's quite a lot of money, $1 million. And what you have to do is, I mean, you can't spend it on buying nice cars and all that. You have to spend it on a research project that you do with it. So I proposed a research project. We would take two ideas, the idea of a self-organized learning environment, a soul, the idea of the granny cloud, put them together into a single facility. We would call it a school in the cloud. You know, many people make a mistake of thinking that school in the cloud is a website. It's not so. Okay? It's a physical space inside the school where the two ideas of self-organized learning and the granny cloud come together. I built 7 of them with the prize money. 5 in India. Actually, I built 9 of them. 5 in India, then 2 in England, 1 in the United States, and whatever we learned from that, I used to build 1 more in India. So the ones in India, some of them were in schools and some of them were in the community, not in a school, like a club or something. The ones in England and America were all inside schools. So this is the last one that I built. You know, brightly lit, transparent, with glass walls so that you can see inside. Remember the big screens? And whatever you do on the big screen is visible to everyone. Very important. For those of you who work with children, if you give children a large screen, and if you allow them to work together in groups, which they make on their own, you don't tell them make groups. If there are 5 computers and 20 children, what else can they do? It's the safest use of the internet. You'll not need any controls. This is the remotest one that we built, This is in Bengal, near the Bay of Bengal. For those of you who remember Indian map, the Ganges River flows into the Bay of Bengal. It forms one of the biggest river deltas in the world. But it's very wild. You know, tigers, crocodiles, things like that, and lots of children. They have nothing. No health care, no schooling, nothing at all. So I built one of these. It's solar powered. It gets a 4G signal from an antenna high up, and that's how we keep it running. It's been running now for 4 years, and the changes in the children are, dramatic. This is the graph of reading comprehension in that particular village. Reading comprehension in English. In an area where nobody teaches English, and in an area where the nearest English teacher is at least 300 kilometers away. You can get this kind of a graph with nothing. This is a village in England called Newton Aycliffe. And I got you the picture because you can see the purpose of the big screen. You can also see the Skype on the wall with a question. This particular session, the question was quite interesting. Why does the color red go with black? Lots of people wear black trousers, red shirt, or that sort of thing. Why is that such a common combination? And the children were, I think, 12 or 13 years old. You would be very surprised at what the answer is, but I won't tell you. This is a school called George Stephenson High School near Newcastle. Again, to give you an idea of the design. Do you see that where I'm standing is actually outside the facility? I'm looking through a glass wall. And even from there, I can see the 4 screens clearly. If you put children into that environment, you don't need controls. This is one more that I did in Bengal. It's a pretty large facility. So what do I have? This is not inside a school, so there's no teacher there. I can't get a teacher in a remote area like that. But I do have a supervisor. The supervisor, in this case, doesn't know anything. Doesn't know how to turn a computer on or off or anything. So the supervisor I appointed said, well, how am I going to help them? What am I going to do? I said, leave it to them. You tell them I don't know how to turn it on, and see what they do. Your job is health and safety. That's all. So he says, what do I have to do? I said, well, you have to come in the morning and open the door. And in the evening, tell the children to leave and close the door. That's your job. Okay, here's what it looks like. He's just opened the door. Well, the language the children were speaking in is a language called Bengali. And it's a pity you don't understand Bengali. If you had, you would have heard the girls saying to each other, hurry up before the boys come. So, in this 3-year study that we did with the 9 schools in the cloud, I haven't finished all the analysis yet, but certain things are very clear now. Schools in the cloud will improve reading comprehension, whether it's in English or in Spanish or whatever language you're you're using. Reading comprehension is, I think, one of the most key skills that children are going to need in the future. Where everything is determined by the internet, their ability to read and understand and discriminate will form a very important skill in their lives. The School in the Cloud does that. Why?